Welcome everybody to the May 30th edition of the Technical Advisory Council of the Confidential Computing Consortium. As always, we are here to help advance the adoption of confidential computing through open collaboration, including open source. Everybody's welcome to be here and to engage constructively. We're also bound by the antitrust policy of the Linux Foundation, and you can check out linuxfoundation.org/antitrust-policy to learn more about what that is. We've got a little change in the schedule for today. Nathaniel has had an obstacle come up, so we are going to strike that from the agenda. We scheduled Marcella and Chad to come in and give a talk about trusted builds, something that they've been working on with the Salsa project. They are not scheduled until the next hour though, so we're going to swap in some material that Kate asked to be covered, and depending on how long that takes, I think we also have a few leftover work items that are either in our GitHub issues. The GRC SIG had a couple of docs that they were looking at, and I don't immediately see, unless Alec would know, people from GRC that might want to make use of that time. And I think those were the main ideas that came to mind to fill the time that Nathaniel would have otherwise spent. Are there any other suggestions for that period?
This is Aditya. I just had a question, probably to Rianne, about this summit that's coming up next week. And if you're going to cover any organizational issues around like booth coverage and stuff like that, or you can take it offline. Just wondering what the thought is there. Thank you.
Kate has asked us to add the slides for this to the end of the deck. So when we get there, Kate's probably going to brief us about all the exciting things happening next week.
Thank you.
Yeah, it's a good prompt, because I think we will do just that during this time. Okay, any other agenda bashing?
Yeah, just a quick thing. The 6/13 date doesn't work for me. I'll be out of the country, and so we talked about putting that back to the 27th, I think.
Yeah, let me go take a look here. So let's switch. No.
And this is Aditya again. I had a related question. Is this the same session where last time, a couple of weeks ago, I suggested that John Manfredelli wants to share some findings of his research in this post-quantum crypto, and there was a thought of having one session where two different tracks are covered. Is that this one or something else?
That could very well be. I didn't retain for myself an action item to reach out to John. Is that something that you would like to do?
No. I have already talked to John, and we are waiting to hear from you all. When might the potential schedule be? If I remember right, there was another person, like a Intel SIG group or somebody, who was also going to share some, investigation on this post-quantum computing. So I'm assuming Hart's talk is about that.
Yeah. And Hart is with the Linux Foundation.
Oh, yeah, right, Linux Foundation. Okay, so I need a date to take back to John asking whether he's available. I don't think he's on the call today.
Yeah, so June 13th looks like if we want to do both of these back to back, or we could do them on sequential weeks, game for just about anything.
So let me find out from him, and I'll loop you on it, Dan, and then we'll sort out some scheduling.
Yeah, that'd be perfect. And then if you can copy Rian as well, he'll do a better job than me to make sure that things actually arrive on the agenda.
Okay, I'll do that. Yeah. Thank you.
All right, great. Anything else for the agenda? The JON or JOHN?
JOHN.
Okay.
John Manfredelli.
Okay. All right. Well, let's check in on roll call. As usual, we don't have voting, but we like to kind of keep pace of this. So we've got Harold from AMD. Thanks. Nathaniel is excused for a conflict that arose. Catherine, thanks again for joining. Always a bad time for Howard. I'm here. Do we have Henry or Kevin? Henry and Kevin. We got both. Great. Thanks for joining, guys. Alec, thank you as well. Do we have a Fritz today? Don't see Fritz today. And Yash, thanks for joining, as well as Ram. And what about Mingshen or Yao?
Are you are you able to make additions to that list?
So these are the voting members that come from the premier groups, but immediately after checking who's here, then this list is only important if we have a vote. So normally I fly by it, but occasionally we want to kind of check in for minuting purposes. But that would bring us right up to this time here where we invite anybody, whether they are a premier member or a general member or not a member at all, and are just here because of their interest in security and confidential computing, to introduce themselves. And we ask that you let us know how you like to be addressed and what your interest in confidential computing is.
Oh, would you like me to do that now?
That would be great.
Okay. I don't know if you can see me. Hi, I'm Mari Spina from MITRE Cyber. I lead the cloud security capability area at the MITRE Corporation. Of course, our mission is mostly government missions, federal, DoD, Intel. So, you know, we recognize that confidential computing is going to be a big part of the cloud. We think it has particular special benefits we want to begin to leverage and employ. There's not a heavy adoption in government work at the moment, but we hope to foster that. We are doing some testing. We do have some programs with the government at the moment. So, for example, the last week's meeting with Azure and talking about how their stuff worked actually really helped in a real-time basis. We were able to then apply it, that fragment stuff, kind of right away. So this is really good. So happy to be a part of this.
Well, it's great to have a representative from MITRE here. So thanks for joining, Mari.
Thank you. It's good to be here. And I think Helen set me up. I met her at RSA, and she's so nice. So thank you for helping me to get connected.
That's great. Thanks for doing that, Helen. And oh, by the way, where are you joining us from? Unless I missed that when you were saying.
Oh, no, I'm in McLean, Virginia.
Excellent. More East Coast representation for us. Thanks. Who would like to introduce themselves next?
I've already introduced myself, Dan. This is Aditya. I was wondering, what is your hat? Is it a Michigan hat or a Gophers hat?
The Gopher hat.
All right, great.
Thanks for asking. Did you want to introduce yourself further? Or
I'm already done. This is Aditya. I already spoke. Thanks.
Yep. Okay. Did you want to mention your affiliation with CCC project?
Yeah. I'm sorry, I'm off video. I work with the certified framework for confidential computing project that came out of VMware, and it's been open sourced and brought under the CCC project's umbrella. So I'm representing a bunch of people, John Manfredelli, Chris Ramming, and a lot of colleagues from VMware, which is now Broadcom. That's what my allegiance is. And thank you, Rian, for all the help that you've been giving continually on everything.
That's great. Thanks.
Great. Thanks.
So Dan, can I go next?
Please.
Yep. So I'm Ram Pai. I work for IBM. I'm the confidential computing architect for the IBM VPC cloud. I'm in Portland, Oregon, on the West Coast. So I've been with this confidential computing for a while now. While I was back in 2019, I was doing confidential computing enablement, bring up on IBM Power. And now I'm into the IBM Cloud, bringing up the technologies to our cloud. So that's my background.
All right.
And I'm a backup to Yash Mankad, who will be representing both IBM and Red Hat company.
Thank you.
Yep.
Great. And I see, Chad, that you've joined early. I appreciate you joining a lot earlier than you had planned. We'll see if Marcella is able to get online earlier as well. I don't know if you'd like to introduce yourself now, or we can do that when we kick off your talk.
Yeah, hey everyone, I'm Chad Kimes. I work at GitHub on GitHub Actions. We can go into a deeper intro whenever I do the talk. I'm actually in the car right now, trying to get to the office, so I will pull over when we need to start presenting.
Okay, thanks. We'll try to time it so that you can get into the office and do that more comfortably. But thanks again for joining earlier than planned. Okay. Maybe one last thing before we move out of this, but anybody else is welcome to introduce themselves if they haven't yet had a chance. Mark, you joined after we did a little bit of agenda bashing. We've got a cancellation this morning that opened up a slot. I think we're going to fill that with some of the summit planning material. But if there are things that the GRC SIG was still looking for feedback on, we might be able to slot that in as well.
We have an early draft that I was hoping to present today, but we actually had a few folks from IBM join, and there is some work in progress still on that. So, I have the document. It's in, it's in Google Drive. I don't mind sharing it, but it's not the final form that I was hoping to bring to the TAC in a couple of weeks' time. So, you're
Okay,
all really.
is that the payload document?
Yeah, payload governance.
Okay. All right. Well, we'll see how time rolls here, and we might be able to do live work on it.
Yeah,
Okay.
Dan, I put together a threat framework, sort of. I'd love to get this group to help vet it, or tell me where I'm crazy, or throw it away and use whatever would be other available.
Okay. Yeah,
I can
we'll
present
do-
that any time. I can even do it today if you need to fill a spot.
Okay, well, we might be able to take you up on that. All right, so let's go into the quick recap of the last meeting. Thanks to everybody who reviewed those minutes. So I think those are already merged, so we don't need to go through that. But we did talk about, or rather, we did have Tech Talk on this privacy preserving data sharing in practice from people over at NSF and the White House. And then we talked about the mentorship work that Yash and others have been leading. And so that's now available for people to recruit in mentees and frame up mentorship projects within their CCC project. And we announced 2 working groups coming out of the most recent board meeting that are looking at how do we update how we are presenting confidential computing on the website. It's kind of listed here as branding, but just in general, being a little bit more use case centric with what we're doing, including letting people see when they land on the website important things like confidential AI and secure supply chain. So in fact, we're going to be talking about an aspect of secure software supply chain coming up a little later today. And then the conformance working group is looking at how do we get more concrete for the industry to help them understand if a solution or a product out there actually is using confidential computing in a proper way. And I think both of these working groups are still open for new contributions. Rian, is there anything more to say about those two working groups?
Yes, the rebranding working group will actually have their first kickoff meeting directly after this meeting. Sorry for the 3-hour meeting marathon, but that's the best spot we could find. From AMD actually volunteered to lead that. So if anybody wants to join that, I'll drop a link to the calendar in the chat just now. So you can just click on the link in that calendar and join us. It would be great.
All right, great, thanks. And then last but not least, we took a look at the objectives and key results that we were trying to do as a TAC group this year and started to get more structured on the cadence that we'll be operating through those. And that, oops, clicked the wrong thing here. That leads to this schedule of each of the premier representatives coming in to lead a working session or otherwise advance one of those key results that we're working on. All right, so that was what we did last time. Moving into today's agenda, we've got these announcements, and I guess Rian just talked through a little bit of this, but or actually, this is actually how we framed it from last time, isn't it?
No, I updated that yesterday, so that is actually announcements. I pre-announced the announcement, so that's what's happening after the meeting. And while I got the opportunity to speak, the link that I dropped in the chat, we've always had some difficulty to get people to join meetings because it's hard to share. There's a great new update to the calendar for LFX, and it's now a web page embedded calendar on the CCC website. So you're going to just send anybody to the calendar. They can find any meeting, find the link, find the recording. Everything's gonna work well from there.
Okay, thanks. And now that you mentioned the chat, I see there's some good dialogue going on in there. I can't always watch that while I'm presenting. So if you're trying to get my attention, that may or may not work. Hank?
Yeah, so this is Hank. Sorry, so I always have like a ton of problems. It was a Google wrapped weird, I have to put something in thing, and in the end, it's Zoom. So I peeled the Zoom link out of whatever that was and just saved it in my own calendar. I put it to the chat here. This is the Zoom link call. That's basically what you need. I don't know why it's so complicated, and I always lose a few minutes remembering what I have to do. So that's a thing, but it's you know, it's just another thing. So it's not important. But everybody who wants a direct link for this meeting, I peeled it out of some wrapper thingy.
And which of the two meetings was that?
So again?
Which of the meetings was that? Because there's a couple.
The meeting you're right in right now. It's for me, it's weird. I only whenever I look at it, it's a Google wrapped something that I have to authenticate with, then I have to put a name in just to end up in Zoom, which is like, okay, but why? And so I skipped these two first steps now and have that directly in my calendar. Maybe that's not even a problem, but just highlighting.
Okay, thanks. All right, let's go ahead and get into the summit material then, please.
I suspected Kate would join us, but I think we might have a clash while in the first part of this meeting. So CC Summit, we're going to have a booth. So people are welcome to sign up to the booth. The email went out to the outreach committee mailing list yesterday, but if you do want to take some time in the booth to talk about your product or how your company is participating in the work of CCC, you are more than welcome to schedule yourself there. I'm scheduled to be there all the time, but I'm more than happy to skip some of my slots and give it away to members to participate in the booth work. Then there's a list of the things that's going to happen on stage, so keep an eye out for that. And Very important. Don't skip over that. Member happy hour. There's a link. I'll drop it in the chat shortly, where you can sign up for the member happy hour. It proves to be very successful last year. So there's only, I think, 50 spaces, and many of them have been taken. So if you're going to be there, make sure that you sign up. Then you can skip to the next slide, please. Okay, then the layout, that's just the general layout of how the conference area would be. You'll see we're going to have a table there on the right-hand side for CCC. It's not all that clear, but you can look at the slides that I'll share later if you want to have a preview of what the venue is going to look like. You can skip to the next slide. Then they OPAID went and they made available a last-minute discount code. So if you want a last-minute join, there's the discount code that you can use to register with. You can share it with people in your company or within your social media group. If you want to share that, you can skip to the next slide. Yep, there's a registration link. We can also
drop these in the chat.
Thanks, Dan. Yes, please do join us there. That's just talking about the happy hour again. Please follow the links and join us. Great to have you there. And then the next slide. Then there is two calls for proposals for talks. So PET Summit in APAC was a good success last year, a very good event to attend. It is 16th of July. So if you want to submit before the 13th of June, you can submit a talk. I think there is 3 or 4 spots available. So please do hurry and submit your talk proposals. And then we're also going to have in September at the OSS EU, we're going to have a mini summit, and I think we have something like 6 slots available there, half-hour slots. That's going to be a co-located pre-event to OSS. So please also submit your proposals to talk there. And I think that is everything from my side.
Okay, great. Well, Mari, since you offered and we've got time available here, would you like to bring up your, was it a threat matrix?
Just a question, sorry, Dashko from Ultraviolet. How, where do we submit the application for EUCC Mini Summit? Is it directly to our outreach team or?
You're on mute, Rian.
Thanks, Dan. So yeah, thanks for the link. Dan just going to drop now that you can follow that link. Or if also you can reach out to me and I'll share the link with you. You can just do your submission through that.
Any other questions on the conferences? Okay. So Mari, you had offered, if you would like, we could run that now. You might be on mute if you're talking, or if you stepped away, we'll try to get back with you later. All right, I assume Mari has stepped away. So Mark, I think you are next on deck if you would like.
Sure, yeah. So you'll just have to give me a second here because I would need to share my screen. I need to pull up this. Actually, I want to show you. I want to show you 2 documents. Actually, one is I think in a better shape, and I'm rather proud of it. So just waiting for it to render here. I double-clicked on it. There you go. It's coming up. Okay, so first of all, let me for those of you who are new here or haven't heard of the GRC SIG, let me explain why we exist. So I work for, I'm ex-Microsoft, 23 years at Microsoft, so a round of applause. And I actually worked as an architect for some of the confidential services of Microsoft, so like deep passion for confidential computing. And then now I work for a large regulated institution, so I work for a big multinational bank. And I can tell you that probably the greatest single driver of adoption for a security technology by a regulated institution, certainly, is going to be compliance, right? So we will do things for security, for sure. Of course, we want to keep customers' money safe, but we'll do it using available means, because ultimately we're not a technology company, we're a financial company. But when regulator comes along and says you have to do a certain thing, well, you know what? And we actually have over 100 of these regulators worldwide. We absolutely have to, because that's the you don't keep your banking license if you don't comply. So we already have history of what happens when the security technology comes along. So we 20 years ago we already had ubiquitous data in transit protection, so SSL or like TLS, whatever, like transport security became mandated, IPsec, whatever, like you have to pick from a menu of choices. But BitLocker wasn't quite available yet, and you didn't have ubiquitous data at rest protection. As soon as that became ubiquitously available, regulators came along, and basically now we have to protect our data at rest as well. And I believe firmly that the same thing will happen with data in use protection. And for that, regulators will have to at some point in time show interest, and they're starting to. But at the same time, what you also need is you need to have clear guidelines on how to comply. Because if you cannot force people to comply with things that are poorly defined or hard to measure. So the GRC SIG effectively exists to ease the path to the creation of regulations that both benefit the confidential computing industry, which is my personal passion, and also benefit our customers and make regulations easy to write and easy to comply with. So in that spirit, I'm going to show you a couple of documents that we've been working on. I don't mind zooming in because I'm sharing a rather large screen. So you should be able to see my screen now.
Yes.
So in one of the documents that we're hoping to formally present to the TAC is going to be effectively this diagram of who expects what from whom in this ecosystem. So it turns out that there are only 6 classes of ecosystem participants, and that we can define in the context of most interactions involving confidential computing what these expectations of ecosystem participants are, and they are outlined here. So again, you can see that there's still comments on the document, and we are still, figuring out some of the details. We like to be very, very careful with our verbiage, but just the fact that we can have this at a glance and say that we, no matter what it is you're trying to do, and we can go through different classes of things involving confidential computing. Turns out that you can still delineate expectations along these personas, these classes of participants in the ecosystem. So this would be one document that I will bring to the TAC as soon as we feel that comments have been addressed. By the way, anyone's welcome to join our GRC SIG calls. The second thing I wanted to show you is this more meaty document.
One question, if we
could,
on that last diagram. So it occurs to me that those might be actors in any environment, not just confidential computing.
You also have attestation verification service providers and component vendors. You normally don't get that as explicitly.
Yeah. Okay. I did not know what AVS referred to there, so that's good to know.
Verification service. Yeah. Okay. So yeah, of course. I mean, this is a superset of what you have. Like normally, you're not going to have a confidential computing environment without AVS, and if your AVS isn't properly governed, then it turns out that a lot of your security guarantees actually are not achievable. So that's, of course, it needs to be involved. And the component vendors, like, if you're doing fully homomorphic encryption, you don't trust the hardware, so you don't care who makes it, and you place no expectations other than perhaps that 2 + 2 = 4 in their chip. But But with confidential computing, you also have expectations that your hardware vendors, the collection of them, perform certain functions. So that's why this diagram is slightly expanded.
Okay, and then is there a relationship with I'm wondering if there's other documents out there that put out a similar set of actors, and whether that would make it more adoptable if it aligned with that terminology, modulo the AVS and component vendors.
I think well, I mean, I don't know if I understand your question correctly.
Just if there's already like an industry standard way of referring to some of these actors, then we can kind of show the differential between that and the confidential computing.
Sure, that's the kind of input we would love to hear when we bring it to the TAC, or if anybody joins the GRC SIG. Of course, like we are not keen on inventing new terms. Sometimes we kind of have to.
Yeah.
But yeah, of course, all feedback is welcome. We are, not the GRC is not a dictatorship, as anyone who participates and it knows. Like we welcome all perspectives, and often they're very, very useful. Okay, so.
Mark, this is Aditya. I had a small organizational question to understand the background of this doc. Is this the viewpoint of the GRC SIG that you're driving, or is this you representing the company, which I understand JP Morgan?
This is no, I actually don't represent JP Morgan. I make it clear who my employer is, but even as far as my employer is concerned, that's for the most part a volunteer gig.
Okay,
like
okay.
I'm not like we have an interest. Like we actually have a legitimate interest, and I'll be at the Confidential Computing Summit with some instructions from my manager as to, what are the kinds of things that the kind of people I want to talk to and kind of information I want to get. But I am not officially representing JP Morgan. That's not. I'm not here in this capacity.
Okay, thank you.
So Hank, you have your hand up.
Yeah. For my convenience, for our convenience, of course, could you share the document link in chat?
I can. You will probably have to request access, but let me do this right now. It's pretty permissive there, but here we go. This is the current document. And again, if you grant access, I get a pop-up in my Slack, and I should be able to grant access fairly quickly. Yeah. Okay. Yeah. So any other questions on this? Because before I move on. Catherine.
Could you elaborate a little bit more on the intended audience and the kind of intended next step for this doc?
So for this particular diagram, this is kind of a foundational document as far as governance patterns are concerned, because it simply says that all the other patterns will refer to these personas. And we'll talk about other patterns. So there is the one I'm going to present next, is confidential payload. So somebody is developing an application and wants to deploy it. And turns out, a number of considerations that apply, that you, in a governed environment, you would have to generate evidence for your auditor to explain that you've met certain criteria. Otherwise, your data is not properly protected at rest. There is going to be a separate document on how you govern your attestation verification service, for instance. So we have maybe a half dozen of these patterns ready to go. That the audience is effectively all these personas. Like, I'm a developing software. What do? I would like to entrust my data to a confidential computing environment. What can I expect? I'm an auditor. Somebody says, that there are these handbooks, FFIEC handbooks, that instruct auditors on how to perform audits of financial institutions for all sorts of things like asset management, architecture, etc. And what do I expect these people to tell me? So I know that they've actually done a good job. We're effectively doing this research ahead of time with the hope to share it with all interested parties and influence all sorts of discussions in NIST, in CSA, that we have a joint working group with. So it's effectively, the grunt work of establishing a common ground.
Okay, great. Thank you so much.
Best done by domain experts, of course. Okay, so so this would be our foundational document, just basically saying these are the participants, the personas, the actors, whatever you want to call them. So this one is, again, it has a number of comments on it, and so unfortunately, you know, I'm hoping to wrap it up, you know, maybe in the Wednesday's SIG before the summit, but it's pretty close. So this one talks about governing a payload. Now, we are following standard pattern writing, you know, kind of I don't know, scheme that has its own you know, document set behind it. But whenever you write a pattern is not a design, pattern is not an architecture. A pattern is saying when you are in this context, when you are finding yourself in this situation, you're going to have a certain problem. And then that's a section on the problem. And then you're going to have forces. Forces are the things that make this problem harder. And then under these forces, you have a solution that's proposed. And after the solution, we will also do a persona thing, referencing the original document that I showed, basically saying, look, for payload governance, the things that affect these different personas are the following. And see, that's actually right now the subject of the you know, most active discussion. This is what I need to close before I bring this to the TAC. But let me just give you sort of the flavor of the type of you know, thing that you have. So I'm going to just read from the slide for a second here. But you know, the problem we see with payload governance. So payload is effectively anything that's going to execute confidentially somewhere, right? It's supposed to protect data in use, right? So basically what we talk about here is that if you just take a piece of code that you wrote and you put it up inside, like basically run it inside a trust execution environment. So yeah, of course, you have access to the instruction set architecture of your chip. It will run, you know, by being packaged a certain way. So unless you're using a vendor, you know, like Anjuna, that, you know, attempts to solve some of these problems for you, maybe most of these problems for you, you are not going to actually have code that protects your data in use. It's just going to be code that, you know, benefits from some of the features of trust execution environments. But you got to do certain things. And so we talk about your code needs to be developed securely. So you need to ensure that all your traffic coming in and out is properly secured. Like, so trust execution environment will not give you, you know, TLS. It will not automatically protect your data at rest that you write out. It will not give you, you know, you have to switch to the use of the, you know, trust execution environment native random number generator. So these are all the things that you need to pay attention to. As a result, you need to evidence them, that you're doing them. And the auditor might be interested in making sure that you do that. Right, and then you need to hopefully squeeze down the size of your TCB. So if, you know, running unnecessary large VM is probably not a good idea, etc. Then we talk about securing your code build and supply chain. Right, a number of problems that occur related to that. Then we're talking about integration, configuration, and deployment. These are all the, you know, forces that make the problem harder. And then in the solution section, we're referencing the same sections. So under secure code development, encrypt your data in transit and at rest, secure your RNG, check out outputs for data leaks, etc. Do your dependency management. Do make sure that your code build is secure itself. You can be doing everything right, except your build chain is sabotaged. So it's a form of a threat model, if you think about it, but also it is a set of guidelines. You know, if you are doing this, these are your checkboxes. These are the things you need to think about. And if you don't, you know, you might be making your customers vulnerable. As a result, a compliance officer might care. So that's the document. And then at the end, again, we're trying to keep them short. These are not, you know, there's the idea is to keep them succinct, cover all the points, but, you know, leave most of the implementation details to the reader. And then the personas, again, the last most active document is, these are the things that you, you know, are expected to provide or you expect to receive as a participant in the payload governance framework. And then, so again, once we do that, the next one will probably be how you govern your attestation verification service. So there we'll be talking about, who hosts it and how do you know that it's hosted securely? How does it's supposed to handle multi-tenancy? How is it supposed to handle other things, whatever we come up with. And again, that becomes part of the governance framework. These are the expectations. This is how this is the kind of evidence you should be expected to produce, and then you effectively can author handbooks from that. So I guess that's again short presentation. Just wanted to whet your appetite. This is what we've been up to for the last few weeks.
This is great. I think this will be really helpful for people. We often talk about the TEE ambiguously as either the technology like SGX or Trust Zone, but ambiguously as well as the thing that you're actually running in there. And I don't know that we've ever really defined a term like payload that kind of makes it clear this is the thing that you're putting into the TEE. For me, that's been a gap.
Yes, not only, but one of the with our other documents is we spent, as you probably know, a few months sort of writing the overall framing document for all of this. That's not for the TAC, but this is to guide our own efforts. And in there, we figured that we kind of have to introduce, looking forward, a notion of what we call a payload slice. So what do I mean by that? Is so a payload is sort of a collection of pieces of code that will run in concert to protect your data in use. But some of that may be running on your GPU, some of it might be running on your CPU, some of it might be running on your some other offload peripheral. And these things don't automatically work in concert. You need to make them work together. So one of the more advanced things that we need to start thinking about is how, even for purposes of attestation, how do I know what the boundary of the payload is? Should we be thinking about like payload slices? Should we think about them in some sort of other way? But confidential computing has, and I keep saying this, if you've heard my presentations or anything, it has in its DNA that it's effectively either a gaming console or a mobile device technology, IoT type technology. It's a single unit type of thing. So there is a trusted execution environment, does everything. Well, modern applications aren't like that. They're distributed. They sometimes operate across GPUs and CPUs and maybe other types of computing devices, maybe ASICs, etc. And how do you even think about attesting such a thing? So I've been bringing this up to the attestation SIG, but these are kind of more advanced concepts that we'll need to figure out. Again, once you figure them out, the barriers to adoption of the technology go down and adoption goes up.
Okay, great. Maybe one other thing in the GRC scope. I believe Olu Oniende from Intel has been participating, and I think she's working on a mapping between compliance requirements and confidential computing capabilities. I don't know if she has teased that into the GRC agenda or not. Does that sound familiar?
Doesn't sound too familiar to me right now. I can tell you right off that existing compliance requirements will not fully cover confidential computing. We need additional ones. And so mapping implies that you map between the things that exist. And here, I believe we need to introduce new ones. But whatever work is done, please bring it to the SIG because we would love to hear it and integrate it however best we can.
Yeah, I think we want both sides of this. We want to be able to influence new compliance requirements as well as make sure that the existing compliance requirements that apply to confidential computing, it's easy for people out there to see those and see that mapping.
Yeah.
So I think there's things in the what's the EU regulation that's getting rid of cookies? It's a GDPR. At any rate, I think there's some
no
language
GDPR just makes you waive the prompt. Sorry, that was a joke.
Right. At any rate, I think there's a couple existing regulations or compliance documents that do have data in use terminology within them. So we want to be able to kind of harvest what's available today as well as create that bigger set.
Yeah, no, absolutely. We're open to all inputs, and please bring this work to the SIG. It will be incorporated, considered, and discussed.
Hank?
All right, that's really it. I will also share the link to this document, so if anybody wants to comment, you are more than welcome, and I will grant access to anyone who asks.
Okay, great. I see
All right.
Hank and Aditya have their hands
Yeah,
up.
I'm sorry, that's me again. So I posted a link to the terminology section in the governance GitHub. It has this, we had discussed 2 years ago and kind of stalled, I think, due to Eric's absence also. We were talking about this packaged software versus the confidential computing guarantees diagram that's in that link. Is that somehow related to what we call payload here?
Yeah, I think it would.
It's still single device from everything I can see, right? So the moment you introduce a GPU, it's a good diagram. I'm sure it can be used in, a good portion of it can be used, and that does show you the various types of technologies. So trust zone, GX, CVSNP, it's a good information. But where's the code that's running on the GPU? How does the code running on GPU and CPU recognize each other and securely exchange information? How is the bundle attested? You don't speak to that here.
Per technology, you have the yellow box, which is the whole software that has threads to run to achieve the goal, and then you have the part of the TE enrollment that is actually protected by confidential computing, and that's the red dotted line. And that as this diagram shows, there's always this outside part that somehow interacts with the inside part that is in the confidential computing domain. And so that is what my question was basically. Is the payload only about the stuff in the dotted red line, or does it take into account that the package software for controlling all of that also has something outside the dotted red line?
I would imagine it's the red line.
Okay.
The payload is specifically what runs inside the T. But at the same time, again, this diagram doesn't speak to what happens when I run something on a device that's what, for lack of a better term, disaggregated. So it has maybe CPU, GPU, maybe some additional stuff. And that's something that I still, I keep beating this drum. I will until I hear sound.
And I absolutely get, but this is just a sector of what you should look at. In reality, you have more than one part that makes up the CC domain, and that's what you want to scope the payload to. Okay.
Yeah. And this is why we thought we kind of started talking about payloads and payload slices. So what you see here is a payload slice. Now, slice may be the whole payload. Like you can't eat an entirety of a cake as one piece, right?
So
but there could be more than one.
Yeah. Okay. Got it. So this is the slice, and you're trying to model the cake. Got it. Thank you.
Eventually, we would like to, yes.
That helped me.
Aditya?
Yeah, so hi, thank you. Mark, this is a naive question about adoption and the audience for this document, similar to what was asked earlier. I think you're trying to create a model so that, there is greater penetration of CC once compliance comes into play. And compliance comes in when regulatory organizations start asking for this checklist, right? Is that sort of what's happening here? So my question is, So my question is, do you have an idea of what are those regulatory organizations that you are targeting to? And can you list some? So say, okay, these are the kinds of regulatory organizations that would want to regulate CC and so on.
So it's a complex question you're asking, so I can also maybe give you sort of a glimpse of the answer. So regulations are not random. They they're kind of structured. You can think of it as roughly speaking an acyclic graph. So there are some things that are on top of the regulatory tree. For instance, NIST would be very high up there with their special publications of various internal reports. And then they, these documents define sort of high level expectations, which are then further distilled. And then an organization like FFIEC is going to come along and actually author handbooks. So if you do a Google search for like FFIEC handbook, you're going to see the structure of those documents. And eventually it comes down to various regulators, distilling these high-level documents into a set of things that now start saying, okay, these are the expectations, and this is the kind of evidence we expect. And we are hoping to do enough research to inform the highest level developers of standards as to what they really should be expecting. So our biggest success so far is we've been able to influence portions of the CSA, so Cloud Security Alliance, Cloud Control Matrix, CCM, and there's going to be a revision of it. These trains move very slowly, right? This is not a NASCAR by any chance, by any stretch. But the next version of CCM is going to have more forceful sort of elaborations of what is expected, and that's of course that's for cloud. That's not the entirety of confidential computing, but we are hoping to, with these documents at the ready, start influencing everything from individual payment devices to IoT to cloud. But it's to answer your question, it's kind of on a cyclic graph where things get distilled from a few top players.
Yeah, basically the question and request was, would it be possible, or is it too premature to say, for example, these are the kind of regulatory bodies who might be, the people we want to influence?
We have a document like that in our GRC drive where we try to identify all the various players, and there are many. And again, I can probably look it up right now and share with you. But yes, we have given some thought to this, and we have our own sort of working documents that include such information.
Okay, thank you. Thank you.
All right, thanks for that, Mark. Good work from the GRC SIG as always.
Thank you.
So if anybody is interested in participating, you can find the connection info for the GRC SIG on the committee's page of our confidential computing website. All right. So I think we've got maybe just a couple minutes to hit the issues in the governance repo itself and do a little bit of cleanup work for just a couple minutes, and then we should have Marcella joining us along with Chad, and we can get underway with that talk. And thanks again, Chad, for showing up early, despite our inability to actually move up your talk. Yeah, share again here. Okay. So this is the terminology doc that was just referenced for people that didn't hit the link themselves. We've got the full text for that in here, and it was published. So that it is starting to age, which is kind of interesting that documents age so quickly in our space. But we're probably due to start making some updates on there. So if anybody would like to file an issue to help us remember the device aggregation problem that should be reflected in that diagram, that would be great. For the issues that we already have on here, one of these is sort of an administrative thing with the repo. So everybody who's got voting responsibility with the SIG should be listed in the code owners and have permissions within the repo. These were recently updated, and I think we're all set here. But it would be good to check with any of the people who are on this list to make sure. But unfortunately, I think we're missing a few of these people today. So no Nathaniel, Fritz, or David. But maybe Catherine, can you verify that you've got proper access on the repo?
Yeah, I haven't checked in the subdirectory, but I do have access to the repo.
Okay, so you should get notifications through code owners when there's things like minutes being posted, and you should have the ability to make like a green checkbox from your review. So if you find that not to be the case, we can reopen this. I'm going to assume that everybody else is good, though. I think the other person would be Mingshen, and we're also missing Mingshen, ironically. So everybody but Catherine. I don't recall. Oh, this is Yao. Okay, and we're also missing Yao. So
Then I
I
have
would like
send out invitations to everybody that that was not in the list yet. So I'll follow up and close the issue if they accept it all, if that's okay.
Okay, so we'll leave this open for now while we'll let you run that out. We've discussed this one in the past, so I'm not going to reopen that one. This is something that every time we have an annual update for projects, usually it's not clear to them what they're supposed to do when they come in for their annual update. And it's a mix of, we want to hear about their project, any news they want to share, technology, and so forth. But then there's also a few governance items that we need them to cover, making sure that they've got good scope, that they've got good quality for things that we're looking for as measured by stuff like the security badge, creating the name of the doc that should be in everybody's repo about community guidelines, things like that. So I don't know that we ever got this template created. So this is another good first issue for somebody working on governance for us in the CCC. And we'll try to hit one or two more of these. In fact, I shouldn't toggle away from this too quick. Is there somebody that would like to put their hand up to grab this one right now? I mean, not literally creating the template during the meeting, but as somebody with TAC responsibility would like to fulfill some of that responsibility by making a contribution here. Wow, everybody's hands went up at the same time, so I guess we can't pick one individual right now, but I'm sure you'll sort that out amongst yourselves. All right, so meanwhile, I have stalled just enough that we are at the top of the hour, and as scheduled, we can hear from Chad and Marcella on work that they've been doing with the Salsa project. And they have, they've got a talk that covers TPMs, Merkle trees, and TEEs in the context of Salsa and secure builds. So I will turn it over to Chad and Marcella to introduce themselves now and their talk.
Yeah, hey everyone.
Hi,
let's see.
thanks. Do you want to share
Marcella, do you want
or
to, or I can do it?
I have it open, so let's see. Yeah. Hopefully everyone can see that.
Yeah, it's coming through here.
Okay.
Do you want to switch to presentation?
Yeah, I'm the Zoom controls are covering my, let's see. So do people see the presentation or the presenter
Yeah,
mode?
kind of swap displays. Yeah.
That's perfect. It worked. Okay, so
Want to swap we're seeing the presenter's screen.
oh, you are? Okay, that's what I was asking. Thank you. Let me stop sharing.
All right, so this is a talk that we gave at Open Source Summit in I guess it was about a month ago. The content might be a little duplicative for a lot of people who are in this in this call, but I think how it applies to salsa is a pretty interesting part that this group might find interesting.
There we go. That looks perfect.
Yeah, that's good.
Yeah. So, and that works too. Okay, great. So, yeah.
All right, let's do that. Cool. So hey everyone, I'm Chad Kimes. I work at GitHub Actions. I've been there since the beginning, since like 2019 when it was pre-beta. I've been mostly working on the hosted runners, so working on scale and security and availability and whatever else it's like necessary to provide hosted runners for all of open source and all of our public customers. I'm also a member of the Action Security team, which is like responsible for both infrastructural security and also looking at product security improvements and thinking through what can we improve about GitHub Actions for to make it better for our customers. You know, my personal interests align a lot with supply chain security and dealing with and building for scalability and working distributed systems. So it's pretty cool that my day job does all of those.
Okay, yeah. I'm Marcel Melara. I'm a research scientist at Intel Labs. I lead software supply chain security research in my group, and I also serve as a TAC member at the OpenSSF and as a maintainer for some of the Intuitive projects in the CNCF. My technical background is in distributed systems, OS level security, and hardware assisted security. So this work here really seeks to bring all of that together. So a quick overview of the talk, and based on time and people's interests, we may or may not skip some of these sections, but we're going to start just describing the status quo of Salsa CI/CD builds, then describe the problem of why it's important to validate build environments. Then we're going to get into the nitty-gritty crypto and hardware technical stuff, and finally sort of end with describing the enhancements we've been proposing to the Salsa framework and some final conclusions. So for those who are maybe less familiar with the software supply chain integrity space, that's what this recap was for. We sort of highlight three primitives: provenance, attestations, and signing. And these mean very specific things in this space, which is why we laid this terminology out. Salsa provenance is a detailed description or record of a build process. So what this really captures is the inputs to a CI/CD build, such as GitHub Actions, the outputs. It captures cryptographic hashes of those artifacts and some other metadata about the actual build platform, who triggered the CI/CD build, and so forth. In total attestations, they are a standard data format for attestations about any aspect of the software supply chain. So when I say attestation here, it's really an authenticated piece of metadata that can be exchanged between different parties. And Intoto provides this standard data format, a standard policy format, and so forth. And finally, SigStore, some of you may have heard of already as well, is an identity management service and public transparency log. So SigStore has its own root CA called Fulcio that hands out ephemeral signing keys to OIDC identities, and then logs digital signatures on artifacts of containers, as well as attestations in this public transparency log. So all of this is just to say that what we get from these primitives is a cryptographic verifiable link between a software artifact and the build process that created it. And we do need all of these three to do so in a sort of cross-industry, cross-compatible way. A refresher on Salsa and the build track specifically. So Salsa is a how should I say, a framework that lays out these incremental levels that help software producers, build platforms, and software consumers both, how should I say, generate integrity metadata for their builds, as well as verify the integrity of a particular build process. So from the just going through these levels, right? Level 0 means you're not doing anything special to improve the integrity of your build process. Build level 1 adds a scripted build. So that is, for example, you have a makefile and you generate a provenance document. Build level 2 then introduces an authenticity requirement to this provenance and adds requirements around running builds on a hosted platform. That could either be an internal enterprise platform or a service like GitHub or GitLab. And then finally, build level 3, which is where version 1 of Salsa currently ends, provides additional requirements for hardening build platforms that sort of prevent tenant-to-tenant tampering during the build. Are there any questions? I'm going to pause here for questions.
I got a quick one. So it's been a while since I looked at Salsa directly. The last time I looked at it, it was phrased kind of at this level. It did not have what you might think of as very specific requirements. I don't know if it's gotten more detailed over time or if it's still sort of at this level.
It is much more detailed. This is just the overview of the 3 levels. If you actually go to the, I forget which page it is. It's like salsa.dev/requirements. That's where you'll actually see the very specific requirements and all of the must do this, should do that, must do this types of requirements for each level, for both what the software producer needs to do and what the build platform role needs to do. So yes, it is much more detailed these days.
Okay, great. And thanks for the link, Chad.
Yeah.
Yeah, this is Aditya. I had a question. Could you go back to the previous slide? I'm trying to understand what this Salsa is. Yeah, right here. Is this a working system or is this a proposal? I also saw the link that was sent out right now. Do you actually have something already working?
Yeah, so Salsa is 2 things. One is this framework of requirements, and the other is actually a data format for expressing this description of the build process. That's what's called the provenance. And Salsa is a project under the OpenSSF, and that project does also provide implementations for generating these documents during a build process. So there are working tools that will generate Salsa provenance metadata, tools that will generate input attestations, and then also use the SigStore service for signing. So this is not, let me also say one more thing. So Salsa itself is not simply a proposal anymore. It is in version 1 and is being adopted by several software vendors. What we are going to present in the rest of this presentation, this still is a proposal. So
okay, thank you.
Yeah, Alec.
Yeah, I just wanted to say that there's a lot of common ground between this idea of a hardened build and attestation of the build environment and the government's and regulatory compliance SIG. Unfortunately, there's not any overlap between your joining and when Mark Novak was presenting. I just want to encourage you to kind of touch base with Mark and with the GRC part of the confidential computing group, because we're writing some documents that have a lot of synergy here, or could have synergy. We're also very interested in protecting the supply chain, and we want to include attestation, confidential computing attestation, what we call remote attestation evidence.
Yeah.
Of the build environment, the build pipeline, in addition to what you've described here. So just a lot of cool overlap. Anyway, just wanted to plug the GRC. Thanks.
Yeah, no, thank you for that. And the rest of our really the core of our presentation is showing how to use hardware mechanisms really to provide additional levels of integrity for built environments. So I think you'll find that there is quite more overlap still than what we have so far. All right,
Great minds think alike.
Yeah, for sure. Okay, so all of this is still just sort of introducing the problem, so I can sort of go through it a bit more quickly. We wanted to highlight a guiding design principle that Salsa typically has, which is trust platforms verify artifacts. PCBs are needed in practice. That's what this principle recognizes. And platforms like GitHub, GitLab, and others have economic incentives to correctly implement these Salsa requirements, to correctly implement security and integrity measures for their customers. Right, otherwise this may impact revenue, reputation, and so forth. So why do platforms need more hardening? I don't think we need to really convince anyone here of this issue. Right, on the one hand, if our platform is handling signing secrets and allowing arbitrary code execution by design, that makes it a high value target. These platforms allow for attack amplification, as we've seen, because of their own large user bases and the sort of supply chain of a producer is also a consumer and so forth. And of course, a CI/CD platform is just a very complex system, which makes it hard to audit. And so this here is just to describe a pretty generalized model of what a build environment looks like in a CI/CD system like GitHub Actions. And so you can really see it's this entire software stack: hardware, software, host, guest, tenant provided information, build platform provided information, plus control plane, build caches, and other components that are auxiliary to a build, but aren't really part of a build environment per se, that a tenant is interacting with. And so the build image in particular, that's your VM or container image that you ultimately run a build in when you're running a CI/CD job, is this build image. It contains mostly actually software provided by the build platform, and really only this box in the dotted line in the top left is provided by the tenant. And yet the tenant actually gains full control over the build image during execution. So that just to show, those kind of security challenges that exist. So we really separate or divide the problem into three areas that demonstrate this unquestioning trust on the build platform. One is right at the first level, I should say, or the first layer. I don't want to say level because of the salsa, but at the first layer, right, build platforms are tested to create a good build image, where good is at least defined, based on what the platform deems to be their expectation. But because this image is created sort of behind closed doors, there's still tampering with the image generation that could occur, and tenants and downstream consumers have no way to detect this sort of problem. At the same time, sort of one layer up, we trust the build platform to supply the right environment when we request one. And again, because there's really no way to check if the environment that we received to run our build is actually the environment that a build platform created, there's this tampering window that could still occur with the distribution of the image. And then finally, we trust the build platform to sort of provide this protected environment during the build while executing the build. So yes, the current salsa provides some guardrails, but there's definitely more needed to sort of mitigate some other vectors for tampering with a running environment. So our approach is we prefer attestations over inferences. This is actually already another salsa guiding principle, just that now we're applying it to the build platform's software layers itself, and we're leveraging existing mechanisms to attest to build environment configuration. So I believe this is where I hand it off to Chad.
Yes, sorry, I was typing.
No worries. I can also speak to this if you, yeah.
No, it's fine. I can hand off. Okay, so great. How do we trust and verify a build platform? So problem number one of like, what do we do to trust to create a good build image is actually already solved by Salsa. Remember, we have this this idea of Salsa provenance. It's a cryptographic link between a software artifact and the build process that produced it. Well, if we're going to generate build images or the VM images that we're running our builds on, then we can simply publish these images with a provenance statement. You can link that back to the build jobs. Customers can inspect it. Great, we've solved number one. But then how do we actually check that? Remember, people consume a VM build image from inside of a VM, right? You don't get handed the VM image and then create your VM and go execute your job. No, if you're the user of a hosted build provider, you are granted access to a virtual machine. So you actually have to be able to validate your environment from inside your environment. So how do we do that? So in order to go through that, we're going to talk about TPMs. We're looking to something called measured boot and investigate how we can do integrity checking of file systems, and finally wrap up with confidential computing. This might be a lot of duplicative content for people on this call. We can run through it fairly quickly. So, quick recap of TPMs. The first thing I want to get across is that TPMs are defined by a very large specification provided by the TCG. I'm going to simplify to the extent that I can without being entirely incorrect. So you can think of TPMs as having a private key that is, inaccessibly burned into silicon, and a public key that can be provided via an API that you can read off of the TPM. Optionally, manufacturers can take that public key for that TPM and they can provide a signature for it. So you can say, okay, if I trust that this manufacturer is not signing a bunch of invalid certificates for their public keys, then I can see a public key and I can see a certificate between it and validate that, yes, this public key probably belongs to a real TPM. So takeaway is that a TPM key pair represents an identity of a single TPM, and the certificate shows that key pair is, like a real TPM. So TPMs have these things called PCRs, Platform Configuration Registers. They have a large number of them. For historical reasons, there's roughly 16 that we have usable in the operating system. Each register stores a single hash length value. So these registers are really just storing hashes. And you can only update the register values in these registers with extend operations. So extend operations have this interesting property where if you always extend the same data into a PCR register in the same order, then you'll always end up producing the same results in the PCR. So what does extending actually look like? Extending is fairly simply taking the value that is already in the register, appending the hash of some new data that is coming in, and then taking the final hash of that value. So we can take a simple example here. We start with the initial value of all zeros. I want to measure the data, this hex string 0x decaf pad. So I hash that hex string. I get the 0x40 value. The new value would be the total hash of appended all of these zeros plus this 40 string. And the new value that ends up in the register is this 0x707 value at the bottom. So this is really interesting, and it maps to something that people actually are pretty innately familiar with at this point in software engineering, which is it's pretty similar to a get commit. A get SHA is a representation of all of the data that was fed into, like all of the history that was fed into leading to that commit. In the same way, PCR values are the same thing. They are a hash that represents all the data used to generate them. So TPMs have these PCRs, but what are we actually going to do with them? Like, great, I can read data in, but who cares? TPMs also expose this idea of a quote operation. And quoting is really just signing. We use that private key that is burned into the TPM to sign a manifest of certain selected PCR values. Verifiers can take the public key and that certificate that says, hey, this public key is a real TPM, and then they can use that to validate a given signed manifest. They can say, great, I know that someone else has a real TPM, and that real TPM has these values inside of it. So we're pretty deep in the weeds here. We've like, here's how TPMs work, but how does it actually apply to CI/CD, right? We're interested in, again, validating a build environment inside the build environment. So how are we going to tie this back? Unfortunately, to answer that, I need to do yet another digression into like a typical boot sequence for a UEFI machine, glossing over a lot of important details. So typically your hardware boots up and it loads the firmware. Your firmware loads in these things called option ROMs, which are like any expansion cards you have will typically have option ROMs included. Think like your network card or your GPU. Your firmware then loads your bootloader from whatever disk device you have. The bootloader is then responsible for pulling in a kernel and inner MFS. And finally, those are responsible for pulling in a file system. So in a measured boot process, you have each step in that boot chain responsible for measuring each of the next step before execution. So remember, a measurement is taking a value that represents whatever you're going to execute and extending it into a PCR. And then simultaneously, you take all of the things that you were going to measure into that PCR and you also write them into a log simultaneously. So what that ends up looking like is that we start with our hardware and we consider our hardware to be the root of trust. If our hardware measures our firmware before executing it, then we can trust that the firmware is doing what we expect. If the firmware then measures the option ROMs and all of the configuration that leads into it, because remember, configuration can change execution. Our firmware might measure our UEFI configuration. It's going to measure the configuration of our boot devices. What's our secure boot setup? What keys are we allowing to boot into, and what keys are we disallowing? The firmware is then responsible for measuring the bootloader. Bootloader measures the kernel, NRFS, kernel config, think like the kernel command line. And then finally, we go load up our file system and move on. So things to take away here are that the same boot chain executed in the same order would result in the same PCRs. And then remember we talked that all of these events are written simultaneously into a log. I can take that log and ship it to someone else. I can have that someone else can then reconstruct the expected PCR values remotely using that event log. So putting it all together, if our hardware is trusted to measure our boot chain into the PCRs, and we trust every step of that boot chain to continue those measurements, we can then use the TPM's quoting operation to sign those PCRs, and then we can validate that quote using our event log and the TPM public key and the TPM certificate. So assuming each boot layer is secure, we can then provide all this information to a third party, and they can validate certain aspects of the system state by following along with that boot chain. So what's interesting here is that note that the file system isn't measured. So most measure boot systems, really do not make much attempt to measure the root file system. And this makes sense to some extent. Like when I turn my computer on, I want to use it. I want to edit documents and install software. And all of that requires a mutable file system. Some prominent counterexamples are, mobile devices today. So Android and iOS tend to partition the drives. So they'll have a system partition, which is expected to be mutable outside of software updates. And then those are measured and attested to. And then the user partition is where things like apps are installed, where all your data is put. So how does this actually apply to CI/CD? So something that's interesting about an ephemeral CI service who is running, single-use VMs with an expected build image is we always expect the disk image content to be the exact same thing. Every single time, without fail, if you re-image a VM, it goes back to an expected state, and that's it. So we effectively, on boot, we can validate everything on boot, even if we add mutability later. So how can we extend this validation to our entire file system in a sane way? So the NRMFS is this, I actually didn't explain it. I should have explained it earlier. Is this like ephemeral execution environment that you boot into before actually loading your file system. It's not a requirement, but it is a very typical thing in machines nowadays. So the idea behind NRMFS is that you load something into the initial RAM file system. So the most common use case for this is disk encryption. If I have my file system is encrypted, well, I need some sort of execution environment that loads before I'm running my file system. And I want the execution environment to have a kernel so I can do, useful things with it. So the NRMFS is where I might perform all of these steps to configure the file system before I pass off execution into it. Well, that environment that exists before the file system is a perfect place to now hook and measure. We can measure the rest of our file system and extend it into some, less used or unused PCR and add that as part of our later validation. So what would measurement actually look like here? A simple option is just hashing, right? You've got a block device. It's a big block of data. Just hash it and then measure that hash into a PCR register somewhere. So this is super simple. It's a nice approach. It is the same approach that's used in basically all of the other measure boot layers. So it's easy, it's conceptually pretty simple. The challenge is that, your Linux kernel could be a few megabytes. Your NRMFS tends to be 20 to 30 megabytes. The GitHub Actions runner image is 60 gigabytes. So loading that from disk every time over a virtualized environment could be prohibitively expensive for running a high-scale CI service. So what are the other options that we have? There exist some technologies called DM-Verity and FS-Verity. They effectively create a Merkle tree of hashes over the values that are in your file system. So DM-Verity is device mapper verity. It just works on block devices. And FS-Verity works on files. It follows your file system. So very, very brief cover of a Merkle tree is that you would pre-generate a tree of hashes that represent all of the leaves at the very bottom here, these L1, L2, L3, L4, these data blocks at the bottom, those are the actual individual sets of data. So you might hash 4K worth of data in each data block, and that generates some hash value. And you can recursively combine these multiple hashes by saying, okay, great, I've got all of these hashes for this area. I can then hash that set of data into a smaller piece of data. And I can do this recursively until I generate one single top root hash value. And if I provide in my block device in the VM disk image, the total tree, and externally I provide the hash value for the Merkle tree, what you can then do is validate at runtime by walking the tree. So it's a logarithmic verification cost. If I go read a single block, like if I say read L1, I can validate hash L1 against the tree, hash 00 against the tree. I can validate hash 0 against the tree, and I can validate hash 0 against that top hash. So that's a logarithmic CPU-bound verification cost that is also heavily cacheable inside the kernel. It's also something that only runs during latency-bound disk reads. So the total perf impact is perhaps 1 to 2% because it's already on something that takes a long time, and it only is it's only visible if you're at like 100% CPU. So what we can then do with this is measure our configuration for our Verity devices into our PCRs. So no longer are we measuring like the entire hash of our block device. What we can instead do is say, well, here is the expected root hash, and here are the devices that we are expecting to be matching these Verity values. And we then result in a very minimal upfront cost. We just configure it, measure the configuration, and we're done. There's no additional runtime cost, or there's a very small additional runtime cost. The cons of this is it's additional complexity that the build provider needs to manage. Also, Verity devices are read-only devices. So you can work around this by doing things like providing an overlay file system, just the same way that containers might use, Docker containers. Or you can also use device mapper snapshots, which are kind of like overlay, but overlay for block devices. So in summary, we have the ability to do remote validation with TPMs. And we also have the ability to do file system measurement using just hashing or these Verity modules, which, by the way, are already in the Linux kernel. They have been for years. All of this technology already exists. So we have this problem. We had this problem of being able to validate VM image provenance from inside the VM, but it's entirely solvable using really zero new technology. Is there a handoff point? I can't remember. It's been a while.
Yeah, I think so. Should we pause for, should we pause
Yeah,
for questions here?
There was a question. Are
Or
we talking about CI as in CI/CD pipeline? Yes. Continuous integration, continuous delivery. The hand up.
Does GitHub have a plan for distributing reference measurements of its build attestation or its build environment? Because there's not really yet a standard for those reference measurements. Keylime has policies, but those are just written in Python.
So yes, our goal is to get something standardized first before we come in and try to implement it, because it might cost a lot of pain and gnashing of teeth if we implement something that doesn't match a standard. There is also some work that we would need to do to like change our images around to support this. Like right now, we would have to do work to support this, but the idea behind this is that we fully support anything that lands into Salsa. So we were following the specification first, implementation later.
Do you know who would be following up on that at GitHub? Because there's kind of an enclave of us that are trying to figure this out.
I would probably be the best contact for that, honestly. And I think Zach Steinler is another like good contact for thinking through how GitHub interacts with OpenSSF.
Yeah, Chad, this is Aditya again. I'm a little curious about, where is all this going? I'm still trying to sort out. Salsa is like an idea. You haven't implemented it. You talk about CI/CD. So there is GitHub and GitLab, and like there are things like Jenkins and so on. Is your solution, like you said, standardization, right? Where is all this going? You guys are going to come up with technology that everybody can roll out, or all of these other CI pipelines have to implement this thing, whatever you're calling Salsa? It's a little confusing to me. That's it.
Yeah, so Salsa, to be clear, is already a thing that all major CI/CD platforms are trying to implement.
Okay.
From L0 to L3, that is already achieving pretty broad industry adoption. We haven't actually gotten to the proposal that we are suggesting here, which is to extend Salsa with an L4, and that adds on additional integrity properties. So
Okay.
we are heading towards that ever so slowly.
Okay, thank you.
Can
questions?
can you talk about the state of integration with the Salsa platform of your of your measurement techniques that you just talked about?
Yes, I think let's go ahead and finish the rest of the presentation, Marcella, and then we can
But
get into
but I just want to make
the-
sure the goal is to you're going to give us tools to use this with Salsa, correct?
That's correct. That is the goal. So
Okay, sweet.
Yeah, and I also just want to clarify, like Chad was saying, Salsa is mostly a framework for implementing the requirements that are laid out in the spec, right? Salsa is primarily a spec that needs to be implemented by the individual CI/CD platforms, but as Chad was saying, most of them are already Salsa level 2 or level 3 compliant. So the tools that we would be providing in addition would just help in becoming compliant with the Salsa specification. It's not that Salsa is its own tool or anything like that that needs to be sort of implemented. But yeah, let me.
Oh, I
go
see. Oh, okay.
forward.
So you'll give us tools to help be Salsa compliant.
Yeah, I think that's a better way to think about it. So I should also say Salsa is
Yeah.
not an ISO standard. It is currently, when we say standardize, it's really bringing it into the Salsa specification, but it is under the Open Source Security Foundation, the OpenSSF. And so, and that is under the Linux Foundation. And so for all intents and purposes, it's becoming the de facto build provenance document format, the provenance itself, and becoming the de facto software producer standard and specification for integrity. Yeah.
Unfortunately, I missed who you guys are. How do I find your stuff?
Can we, how about we share some contact information on the chat? I think that'd be helpful.
Oh, great. That'd be great.
Yeah. Diana? And hopefully I'm saying your name correctly.
Yes, that's correct. There is a similar effort to gather up reference information about binaries in the CORIM standard. And when I brought this to Hank and the others, they didn't like the JSON. I did see that there's an issue to compactify the representation. Is there any appetite to provide a CBOR facade to the information model?
Yeah, that's a really good question, because ultimately I personally would like to see some more cross compatibility there. I don't know that there is a big appetite for that though. I think most people tend to see that as there just needs to be a tool that translates the JSON to the CBOR format. Yeah, the reason why JSON, I think, has just become the main encoding is that, yeah, that's what most other tools in the ecosystem seem to be using. But I don't know that Salsa is strictly beholden to JSON either. So if there isn't already an open issue, then we could. It's just a matter then of what the community is going to prioritize. But
And just a time check, we're down to about 15 minutes.
Yep, thank you. We don't have much more. Anyway, we're sort of just jumping back in. We're sort of trying to work our way through the different trust layers or trust expectations, I should really say, for a built platform. And so what Chad talked about really addresses the second layer here of trusting to supply the right environment. There's still the, I should say, integrity during build execution piece that isn't covered by TPMs and Verity. So this is where, on the one hand, we want to actually address this by binding the build execution to its environment in a verifiable way. The way that we can do this with more or less existing technologies, again, because that is one of our main principles, is to essentially include a unique build execution ID. So think of your GitHub Actions job ID, for example, that is already assigned to each run and each job. Take that ID and actually bind it through a TPM attestation, for example, to the build environment that it's running in prior to executing the build. And when I say prior to executing the build, I really mean prior to handing off control to the tenant. The goal then is to enable detection of tampering with the build environment during a particular build execution. This is where TEEs come in. TEEs are very specifically designed for this kind of execution time memory protection. So I don't know that I need to really go into very many details on TEEs in this particular group. What I do want to point out is that TEEs are programmable, unlike TPMs, and they support the same measurement, coding, and extend operations sometimes, depending on your TE implementation. This is why we think that actually, just to preface a little bit, all of the operations and sort of boot time measurements and checks could be implemented using a TE as well. So we highlight CPU-based TEs just to be very clear and explicit about the types of TEs that we're referring to, and that we're targeting for this kind of work. So what's important here? Some of these TEs hardware encrypt memory for protection of code and data in use. If we want to extend measurement to the file system, that does still require one of the Verity mechanisms that Chad presented earlier. But what's important to know here is, the remote attestation that is already built in as part of the TEs is just advantageous. We don't need to develop or implement a separate remote attestation protocol as we would with TPMs. So we're specifically focusing on confidential VMs for builds. As you all know here, provides a hardware root of trust for the attestations about the various integrity measurements. The VM granular memory encryption provides just this broader coverage of the memory. It's not just like an SGX, for example, that's very process granular protection. And from an adoption standpoint, confidential VMs match the programming and deployment model of today's CI/CD platforms much more closely. So hopefully you can see how all of this provides, with the remote attestation capabilities, with the integrity and confidentiality enhanced properties, we can provide those extra levels of protection during a build, even after control has been handed off to the tenant, I should also add. So I don't know, Chad, if you want to pick this back up or if I should just go through these enhancements. Maybe this is another place where you can stop for a question or two.
I have a question.
Mhm.
What salsa has to do with confidential computing?
We will get to this right here, actually.
Yeah, it's
So,
more like what does
yeah.
confidential computing have to do with salsa? That could be a good
Yeah.
interpretation. So what we're interested in doing is extending salsa to add new build platform requirements. Basically say, if we're going to have a build image for a virtual machine, that build image must have some associated salsa provenance attestation. It should have a build process. We should be able to inspect that build process and cryptographically tie the artifact, for the VM image to that build process. That also means that the boot chain and the disk image of the build images should be measured and hardware attested, so that you can investigate the boot chain from inside your VM. Then we also must say that, we must tie the execution ID, so think of like a GitHub Actions job ID, and bind that to the build environment via this hardware attestation. So the idea here is basically the build platform at a minimum should be performing verification on your behalf and then tying your job ID to that ephemeral TPM ID or to your confidential VM ID. And part two effectively means that you can also perform that validation yourself inside of your build job. And finally, attestations must be verified before passing control off to the customer. That's effectively repeating what I said before. It becomes easier for software producers, so people who are actually consuming a build platform, think users of GitHub or GitLab, they simply must run on a build platform that meets the hardware tested requirements. And they should then, at least verify that those build platform attestations are working as appropriate. Marcel, I think we actually should extend this a little bit more, which is just like you should provide the attestations from the build platform into your provenance output. It's not clearly stated, but I think we've always implied it.
Yeah, it's not clearly stated, but that's a good point.
Hey, but doesn't this bind you to, I mean, you then, I'm not able to move the virtual machine, right? Because then I get a different TPM if I try to, or I get a different VM. Well, there used to be virtual machine move capabilities, especially when the hardware was going down.
I see.
What does that? What does this do to that?
So yeah, it's interesting. With VTPMs, I don't think that there's an issue there because VTMs are implemented by the compute provider and that state would transfer. In the confidential computing scenario, I'm actually not sure. I need to think through that. I think at least in Azure, as far as I'm aware, VM moves just don't happen on confidential computing at the moment. But I know there's a lot of work to try and make that work. So that'll be interesting for me to investigate.
I think we've seen migration supported in different places, but if the question was really like, if I run this on one machine, but then I run it on a different machine, am I going to have different measurements? I don't think that should be the case.
But the TPM changes, right, as I move from machine to machine, doesn't it?
Well, just so we don't mix apples.
Give you a physical TPM. They do a VTPM.
Okay.
So I think for confidential computing, it's a little bit more interesting because you actually are on a different device.
Okay. So this was the virtual.
It's a good question. I think it's good to think about.
So this was the virtual TPM that you were tying to. Basically,
at least if you're using a cloud provider, yes, that's the idea.
Okay.
Chad, I'll just jump in here really quickly. You should probably get in touch with myself and some of the other folks in Azure Confidential Computing. There's a new type of confidential VM called a stateless confidential VM that uses an ephemeral VTPM that gets around some of the problems of file system integrity that you're discussing right now. Tons of overlap. So let's just touch base when you get a chance. But getting back to your initial question, live migration for confidential VMs is not currently supported. Dan and his good friends at Intel are working on new hardware facilities that will make that a reality in the future, but we're not there yet.
Great. Catherine?
Yeah, just some clarification. So I think in Google Cloud, we have live migration support for SEV-based confidential VMs. But the attestation story for SEV is very limited. So, but for SMP and TDX, of course, we don't support live migration yet. Very same to the other cloud providers. So I do have one clarification kind of question for this. So this depends. What you presented, it depends on the availability of the TPM. You're not making use of the attestation abilities of confidential themselves. But in the future, do you plan to integrate attestation abilities from confidential itself?
So the spec itself is written to be inclusive right now of either hardware or virtualized hardware attestation technologies. SALSA to some extent is both meeting the industry where they're at and also trying to drive improvements across the industry. So with that in mind, I think we have to, right now be inclusive of VTPMs. In the future, and sorry, the spec is also written to say that you can use confidential computing as well. Both of those are applicable. That could be restricted in the future if confidential computing is more broadly available and like it's actually supported by a cloud and all like the edge cases are worked out, like VM move for example. But right now the spec is inclusive.
Okay, thank you.
One comment on the migration piece too. I think a lot of build jobs tend to be very short-lived as well, right? So I don't know that, I mean, this is probably something you could speak more to, Chad, but I don't know that migration is going to be as much of an issue with the short-lived build jobs. Maybe with some of the, excuse me, some of the longer running ones.
I think we have to accept that a VM can always be moved. Like,
sure,
we do have 6-hour jobs, and while like the likelihood of encountering a VM move is low on a 6-hour job, it's still possible. So,
yep. All right. So, we've reached the end. All right. So why are we doing this? What are we doing and how, right? You take nothing else away from this talk, right? Build platforms aren't immune to security compromises, and this is why hardware-assisted build environment verification is the approach we're taking. We're using these technologies to increase the default security level of the current state of the art. And SALSA as an open standard framework through the OpenSSF has been so far our vehicle for enhancing build integrity. As Chad was saying earlier, most CI/CD platforms are really sort of getting behind this framework and implementing it. So this is where the standardization part comes in, and we do have a POC implementation as well, but that is still ongoing. Any final questions? I see we have about 2 minutes.
Great talk, super useful and needed.
Thanks.
Yeah, likewise. Thanks for both coming today and dealing with a little bit of a scheduling change right before the meeting started. I think this idea of being able to attest to the artifacts or to attest to how they were built really starts to close the loop for secure software supply chain. we talk so much about attestation in these meetings. We've got a completely separate attestation SIG where we talk about all things attestation for confidential computing, but not to be able to, Hesham, could you mute, please? But not to be able to attest to the origin of that software to begin with is a significant gap. So I think this work is great to close that up.
Thanks. Yeah, we'd really like to have other people's inputs. I know Diana has already been looking at the spec enhancements, so that's been very, very helpful input. If others here, yeah, can provide other perspectives, that's also helpful. We have an open PR currently to the SALSA specification to include this new level 4. So that is underway.
If I could prevail upon you to join us on the GRC SIG working group of the CCC, not the next meeting, because we've already got a presentation, but maybe the one after that, and do a little bit of a deep dive, because there's just a ton of overlap. We're wrestling with the same terminology and the same issues.
Could you put a link to that SIG, to the SIG site for that?
Sure.
Is the event, the meeting on that CCC schedule calendar?
Yes.
It should be.
It is. I'll post my email here, Marcella, and maybe if you send me an email, or Chad, you can hook us up since you've got my contact information. I'll make sure you guys get a calendar invite, so, and we can formalize, make sure the dates work out and everything.
Yay, thank you. Nice.
Yeah. I'm just adding my email into the chat. So yeah. Thank you.
If I add my email, I'll get an invite?
Yep. Or send me an email. That's probably a sure bet, because I think these chats kind of vanish into thin air as soon as the meeting ends.
Yeah, in about 10 seconds, everything in this chat disappears forever. So.
Oh, shoot. And that was Dan talking? Uh-oh.
Yeah.
Wait.
Yeah.
Wait. Where's your email, Dan? Shoot. Did you put it in? Oh. No, that.
Alec, that was offering Al Fernandez at Microsoft.com.
Oh, that was Al. Hi, Al.
Yep.
Wait, don't take it. Okay. Okay, I got it. Thanks, guys.
Okay.
This has been great. This has been great. I love this meeting. Thank you so much.
Thanks for joining. All right, thanks everybody. We are out of time for today. Great meeting as always, and stay productive over the next 2 weeks, and we'll talk again live after the summit.
Apologies, but just last word, my email address, alfernandez@microsoft.com, is in the chat. I'm a representative of the GRC. Please send me email, because I see a bunch of email addresses in there. Mary Speen, I've got yours. The others I don't have.
I just sent you. Yep.
Cool. Thank you.
Nice work, guys.
Thank you.
Thanks, everyone.
Shoot, this move quick enough. Oh, Marcella, yeah, Marcella, yeah. Wait, Marcella and James. Mhm. Hi, guys.
Hey, Marty, how are you?
Good. So good news, right? All good news, I think.
Great news. The paper's ready.
Yeah, it came pretty quick. Oh, good. Did he? Yeah. Yeah. Did it come from him? Okay. Yeah. Good. Did you tell him we added the critical infrastructure? Thought you might. Okay. Okay. So one thing. Okay. So Melanie, is there a way we can get that posted to our public site? You know how to do all that? Okay, great. Everybody on this email should have received the paper that's going to come out. Okay. And then David, today you wanted to nail, I think you wanted to nail the invite letter and the invite list and then be pumping it out, right? Katie. Can we get Kara or Dina, could you pull up what we're looking at? Okay, and I wonder why, let me see, we could use John Weiler, right? Did he bump himself off?
Extended journey. Yeah, apologies for being so late. Dave, I was meeting with Bessie and Stephen over the PCS question. So
Okay. Wait, what about Mills? What about Mills? You want to cross them out? Mm-hmm. Yeah. Uh, How are we getting to Julian Petty? Julian Petty, Major? How did that one come up? Yep, good one.
Send this as Kara. Can you send this to John whatever he needs to contact? Yeah. Let me reach out.
Petty. Are you working with Julian Petty? How did we get Major Petty on there? Do we know?
About some. What he's doing, John. That's fine. That's fine. Let's push him. This topic in terms of let's take. Um, focus there. Okay. Sorry, John. Sorry, John. Yeah, which one's Leo? Can we put? Can we're gonna put Leo in place of someone? But he's from DOD. So, so Yes.
Can, are we gonna send the email invites out at all? How we doing? Yeah. Yeah, I think we need to, yeah, so I mean, is our approach, because we started that letter. Yeah, John, David, we were, the team was working on getting contact info for all the names that were on this list. And we were gonna send out, and the letter was written and drafted. In fact, David, you signed a version of it. Melanie wanted you to review it one last time. And we were gonna go out with email invites to these folks, right, team? I'm not saying anything that we weren't gonna do. And now, and so your reach out, so what I don't know, so maybe your reach out. So David, we got to be careful that we're not doing this all by person, you know, by personal, then we're single thread dependent. So what we should do is let's get no, but here, right. So, but let me finish. Let's let it go. Let's let the email invite go out to the contact info from the team, and then copy to David, myself, John, all the leads, John Yo and all, Tim Suter and Tim, John Suter and Tom Suter and Tim, and then let's take from that email and then reach out personally. How's that? No, so Dina, we were going to do it, right? Wasn't that the approach? I think, yeah. Oh, hold on, we got to get confirmation. So who was heading that up? Yeah. Okay. So who was heading our charge to get all the contact info? Was that Dina? Melini. Okay. Melini, do you? So I'm a little leery. David, I'm a little bit leery about why we started crossing names out. That we've been, go back to the panel one. It's not right. We got too much headache there. Okay. Leave Petty on. I'll keep reaching out to Petty. Leave Petty on, please. I'll reach out to Petty. Copy me on the letter that goes to him. Do we have Petty's information? So Melanie, tell us who on this list we don't have. Cross out DeRusha, Mike Duffy, cross out Mill, leave Petty. Now, so who? Okay, put Duffy back then. Okay, so we need you to follow up. Yeah. Hmm. Gurpreet is Gurpreet. Gurpreet. Now this list, Dina went to ATARC and they posted it, correct? Yeah, we need to get the invite out to this list. Let's try not to change it too much. And let's go after getting these people, whatever it takes. Okay, so Malini, yep. Yeah, I'm pinging him now too. I need to know what Melanie wants to do about the missing contact info. And David, I don't want you to hold up the email. Let the email go out. You just try to beat it, okay? You know what I'm saying? Let the email go out and then you try to beat it if you want to get the personal touch. Yeah. Okay. So Melanie, who you missing on this entire list? Yeah. Yeah, I knew it was gonna. Okay, I knew it was gonna put a ripple change in the names. Yeah. Okay. We got to set a time limit. Can we, the plan to be to get all those emails out Friday and John, David, myself, I'll reach out, copy all of us on that. You could blind copy us. And then I'll start reaching out to folks myself too. But I'll handle Petty for sure. Like I might have a connection with the Zscaler guy as well. Someone's coming in. Oh, oh boy. Okay. What, Rich had a comment. What'd you say, Rich? Patrick Fox. Patrick Fox. Can you do you have his contact info? Put it in the chat, maybe? Yeah. Is requirements and participants for an effective national cyber feed from real-time hyperscaler feeds. So John Yo just asked me, he said, I have a senator candidate with a cybersecurity background running in Oklahoma. She could bring a good perspective. Would the July event be a good fit? What do you think? Huh? Yeah.
Have people that we could talk to.
Well, we're in trouble. These guys are all goofy. Okay. Yeah, what you want to talk? I got I got Nancy Sumption with me. She might have some ideas. I want to just you want to- We took John. Our folks. It's open. Sunoco. Yeah. Is that the one? On Sunoco?
CrowdStrike.
CrowdStrike?
Vivian's gone.
Oh, Nancy
So,
has a
hey,
CrowdStrike.
this is Nancy's assumption. So I'm happy to think about some other folks that I think on the security side, CrowdStrike might be a good place to have. There's a former senior official that actually helped, if you know about CrowdStrike and what they are, that founded CrowdStrike. He's a former FBI, etc. I also have several contacts in that I can maybe help you guys on the security side and with the CSPs with some probably former senior officials that came particularly out of the national security realm. So happy to talk about that.
We could use names and contact, and then
Yeah.
we want to send the invite email out ASAP because we're only looking at about a month. And then we'd ask you to follow up with the personal touch. What do you think, Nancy? But you got to give us the name so we can get the invite out. And
Yeah.
we got to have at least their email.
Okay. When is the thing? When is this happening?
July 1st. Is it afternoon? It's afternoon of July 1st. That's a Monday? Is that a Monday?
Who do you want?
This panel, we want govies. We want govies who understand data and
But
cyber
who do
and
you want from the private
monitoring.
sector? You want technical people, right?
Yeah.
Right, but in the private sector, okay. But on the private sector side, right, because you have companies up there, you want the counterparts, right? So you want CISOs. Yeah, okay. I got it. Yeah, Phil is great. So I think if you can get I know other folks in the private sector. Let me get those to Maury.
Yeah, yeah. That's fine. The formal invite goes out tomorrow. You got a few days to beat them to the letter if you want. Be good to have those names now, Nance, because we've got the team working on getting contact info. If you could draft the names. Well, we can send a letter to them and then you can follow up. No. I kind of need to get it out. We're getting late.
Who do they have from IBM? Who do you have at IB? Who do you have at IBM right now? Like in your list to invite.
Joe Dahl. Joe Dahl.
Yeah.
Panel 2 is panel 2 is the technical, panel 1 is the more policy. Oh, okay. Okay.
Let's talk.
All right. I'm getting a little pinched though.